All right, everybody, it's 11 o'clock, so we're going to get this webinar started. I'm excited about this episode in our series, Saving Money in Oil and Gas Operations. Now, today's focus, our episode, we're having our subject matter expert, Chad Dorsett, join us today, talking about plunger lift optimization and LOE savings. Now, the series is created to focus on conceptual design, ongoing operations, facilities, all the way to plug-in and abandoning. Now, the reason we created this series is we wanted to interview the subject matter experts to help share knowledge throughout the industry. We really wanted to kind of get more control. There's a lot of anxiety going on with election year that already kind of destabilizes oil and gas, make people more cautious. But now when you got protests, riots, COVID, oil and gas prices down, we really wanted to focus on the things that we can control. So that's the reason why we bring on these subject matter experts onto this series. So let's kick it off. So before we get started, we want to do a little bit of housekeeping. Now, if you're new to Zoom, there's a Q&A box, question and answer box, that you can be typing in your questions throughout the presentation. We will try to answer those questions through the presentation, but we will have a Q&A section at the end that we will touch base on. Now, a lot of us are working from home, remotely. Power might shut off, kid might walk in, something might go wrong. Don't worry on that. This will actually be uploaded to our blog with a transcript, so that way you can do a control search function, or you can look at it on our YouTube channel. Now, what I want to introduce is the speaker. So my name is Cameron Croft. I'm the CEO of Croft Production Systems. I've received my bachelor's and my master's from the University of Houston in mechanical engineering and project management. Also receiving my black belt in Six Sigma, so I'm really excited about data, continuous improvement, meeting with other people that have great ideas to share. But I'm really excited about who our subject matter expert is today. His name is Chad Dorsett. He is from Impact. He recently got promoted to Director of Operations for Impact in the last 6 months. The reason I like talking with him is he's got a very wide range of experience, being with ConocoPhillips, Premier Natural Resources, and Intervis as an operator and production foreman. He's literally been in the trenches. He's had to work with vendors, had to work with field techs, field engineers, how to optimize things. He's just got a lot of good information. But here recently, he actually joined Impact. So this is a company that specializes in plunger lift and artificial intelligence. Now, I asked him a series of questions coming on board. You know, what would you want to focus on? So Chad put together a list of topic highlights that he would love to talk about, listing them out from plunger optimization, conventional versus fast fall. And then his big focus always when he was an operator was lowering LOEs, especially in a down market. So these are the items and topics we're going to be covering today. Now, in our introduction, I've already spoken about our webinar. What is our goal of creating this webinar series to bring in these subject matter experts on? But Chad, I really want to ask you, why did you want to come on?
Well, the biggest reason that I wanted to come on is, I've been through several of these, what we call downturns and plummets in oil and gas prices. And so the biggest thing that we focused on as production foremen and superintendents is how do we withstand the storm? How do we come out on top and not have to cut, production so low that we're, laying people off and having to really make those tough decisions on who stays, who goes type of deal. So any information that I've got that I can share that will help anybody in production ultimately is going to help all service companies, Croft, Impact, the water haulers, all those guys that need to stay working and be able to take care of their families. So anything that I can do and talk about that's going to help someone else lower their LOE so that they don't have to lay someone off, or so that they don't have to shut all their production in and ultimately end up losing their job, I'm more than happy and willing to share.
Oh, no, I appreciate that. And we keep saying LOEs. If you're not familiar with that, that means lease operating expenses. So that's I would guess you were kind of graded on that, right? As a production foreman, what are your
Oh yeah.
expenses?
Yeah. So, and what we determined was the most expensive thing in operations was compression and water disposal.
And
So,
we're talking about that later, right? I know you got some good stories that I definitely want to listen to later. Because on your first one, on your topic highlight was plunger optimization. So I know you got a whole slide dedicated to that. So what do you mean by optimizing?
if you've got and a lot of companies that are new to, plungers have been around for a long time, but a lot of companies that are new to plungers and getting them to run and trying to optimize them to where your well's producing the most efficient way that it can, they don't realize that some of the equipment that they've already got on location, like your total flow, your ABB boards, actually have more features built into them to optimize plungers, rather than setting what we call a standalone box at the wellhead that will only optimize your plunger based off of times. And that's really not optimizing the well and your production if you're doing everything based off of times, like shut-in time, after flow, that type of thing. So when you get into plunger optimization, there's things that you can look at, like critical flow, load factors, your differentials from your wellhead to your lines. There's so many different ways to optimize a well. And then you add, GAPL, which is gas lift assist, to, plunger lift. And if you don't have everything set up, you'll inject and inject and inject constantly for 24 hours. And ultimately what you're doing is you're holding the well back because you're just pressuring up your formation, which is pushing everything back into the reservoir. That's not what you want. You want to bring everything to surface, and you want to lower your delta P from the formation to your cells end. So if you can lower that DP and optimize your production, you're going to get more production and you're going to be more effective and cost efficient. You're not going to tear up equipment. You're not going to have your lease operators out there for hours and hours at a time trying to troubleshoot this and that, because they already know, hey, this is where my problem is.
Mm-hmm. Well, so plunger optimization, so like in Six Sigma, it's always identify your resources. And that's what you're saying is kind of do a equipment inventory of what you got on location. And then what were the critical factors you were looking at? Like, I guess, what were the thing you would tell your technicians, go out there, they would bring you in the reports. What were you trying to identify?
So the first thing you identify is currently what do we have in the well? So what are we running? What depth are we running? Where do we set our spring? Is it set in a seat nipple? Is it set on a tubing stop, collar stop? Where is our spring assembly set? And how much water, how much condensate, and how much gas production do we have on that well? And so that'll determine what plunger, what style of plunger you're going to start with, what you're going to go with. Do you have scale buildup? Do you have paraffin? I mean, is there any issues within the well? And the person that knows that better than anybody is going to be that lease operator, because he is closest to that well every day. He's the one that goes out there and checks and tries to troubleshoot and try to get more production out of his wells. So that's the person that you talk to. And so as a production foreman, I would hold, what is it? I'm brain dead right now. So I would have well reviews on their wells quarterly. So every quarter we would sit down and go through a well review, and we would look at their production, and even in Carte, which is a production data collection that we used at Intervest and Conoco. And so when you get in there and you start looking through their production and you can see a trend, well, production was good and on a good uplift, and then all of a sudden now production fell off. So what happened in this area that caused that? Mm-hmm. And then there's some wells that we drilled and we're a year into production, and the trend has flattened out and is now starting to take a slight dip. And so that's the time, you're looking at production daily, but when you see that production flatten out and that curve stop right there, to me, that's the time that I wanted to put my plungers in, because then maybe I can stabilize it there and not see that dramatic decline on that curve. And it helped quite a bit when we would install early, as far as getting plungers in there.
Was there I guess a common mistake that you would see and a lot of operators are trying to, I guess, optimize a plunger? Yeah, was there something like a big key you would always tell your people, or well, now your clients, but at the time you were your own client, that you would catch them doing?
The biggest thing was if a plunger missed a run or something, they'd go give a tremendous amount of shut in, or they'd go add more injection. So everybody's always got a toolbox, and that toolbox, you've got, all these tools, but the first thing everyone wants to grab is the big hammer. Well, on wells, if you've got compression, the big hammer is compression. Hey, let's just give it more injection, and that plunger will come back and it'll start running again. And that's the wrong way to go, because more injection means you're pushing everything back into formation. You're literally holding the well back. And so the biggest thing was teaching them to trust the computer system and to use that automation that was on the wells, rather than thinking that they had to, do everything based off of times.
So on that, you very well, and that's a good segue into on the next topic you have. So on this one is identify the resources that you got, and then you got to hit those metrics. You got to understand the data. So pull the correct data. And I like what you said about the quarterly reviews. Is that commonplace? Do you see that throughout the industry?
A lot of companies do quarterly. Most will do yearly reviews. But like, say if I saw a route, because I was in charge of 6 routes, and each route had anywhere from 50 to 65 wells on each route. And probably 80% of my wells were plunger wells that were gapple.
Wow.
So my guys, if I would go through their production, because I did a production report every morning, and it showed me what their top 10 problem wells were for the day based off of yesterday's production. So the top 10 wells that were going to be down in production for that day, it would flag. And then I went further and built an Excel spreadsheet for my guys, and I could tell you exactly which route was down the most throughout my field. So I could go in and I could pick, and see, okay, well, this route, maybe we need to step up and do our well review early and try to figure out what's going on here.
So you would have almost like a red flag indicators of, now we got to focus our attention. Something's really off on this one.
Yes.
Yeah. That's awesome. Well, I know, so kind of segueing into your next one was automation versus standalone boxes. And that's what you were talking about. So tell us what's the difference between just a Timekeeper box and a box that actually, Impact has. So
a Timekeeper box, which is what we've got shown here on this, and every plunger company has their own style of box, and each one of them have different functions. So when I was a foreman, the biggest box that we used, when I had a superintendent that didn't believe in automation, didn't like it, so we used IPS boxes because they had some features that were easier for the guys in the field to understand. This Timekeeper box here, it's really user friendly. It's kind of, I don't want to say dummy proof, but is dummy proof, to where you really can't mess something up so bad that you can't get it back easily.
Yeah.
And every bit of the instructions are right there on the inside of the panel. But these boxes, no matter how smart the company says they are, only can do so much based off of because that computer in that box is, it's nothing like what you're going to get with a rock or a total flow ABB or our IDAC system that we've created. So these boxes are built honestly just to run your plunger based off of the times you enter. And a lot of these standalone boxes don't have the capability of communicating with your signet. So your guys can't see what's going on with that plunger until they come back the next day to go through and check and see, well, how many runs did it make? How many did it miss? What were the average run times? And then they make an adjustment, and that adjustment's there for 24 hours. So if that was the right adjustment and you did good, you don't know for 24 hours. But if it's a wrong adjustment and your production's going to fall off and you're going to lose your tail, you don't know that for 24 hours. So the biggest thing is being blind, because if the guys get out there and that plunger's missed the last 10, 15 runs and he has to spend 2, 3, 4 hours trying to get that plunger running again, versus he gets a alert on his phone or his computer saying, hey, plunger's missing runs, plunger missed last run. Our guys would get text message alerts on their phone if a plunger missed a run. As soon as it missed one, the quicker you catch issues with the plunger, the less you're going to spend getting that well back, because you're not going to completely load that well up. So the faster you can identify those problems and see those problems, the easier it is to optimize, and the easier it is to get your well back if something happens. Line pressure spike, the plunger quit missing runs. The plunger is just absolutely worn out. Sometimes guys will leave these plungers in and they think, oh, it's good, it hasn't missed any runs. Well, the day that it starts missing runs, you should have pulled the plunger 2 weeks ago and seen that one whole side of the plunger is completely gone. It's just worn out. And so the biggest thing is that helps as far as automation versus standalone boxes is automation will help you identify problems. It'll help you cut your lease operator's time in the field. And that time is valuable, because if they're not sitting there messing with plungers and trying to get plungers to run and get them to run efficiently, they've got more time to fix broken parts, fix little things that, normally they would just, walk by and hit with a crescent wrench to shut it up while they're on location and move on. Now they've got time to spend fixing these little things that is going to ultimately help you save money down the road, because you're not having to call someone else to come out and fix it. You're a lease operator. Part of at ConocoPhillips, we weren't lease operators. We were what they called MSOs, multi-skilled operators. So we changed our own chem rays. We changed our own seat and stems in our chem rays. We changed dump valves. We changed hammer unions. We did everything on location. The only time we called out a roustabout crew is if there was a major project to be done. Otherwise, we called the person that was ran our sister route, and they came over. We put pipe wrenches together and we knocked it out. And they were pretty strict on overtime and all that. So it wasn't like we were getting a whole bunch of overtime because we were fixing all these parts and these issues. It was, we had automation. We were taught to use the automation correctly, and we had the training to use the automation correctly. So we had that extra time to fix little things and little issues that popped up in the field.
So that standalone box is, like you said, every 24 hours. If that person is doing it every 24 hours, that's a one time. They're assessing, everything looks good, and then they input one time. When automation, you can set it where it's making changes every 10 seconds or
so. In automation, so the greatest thing about it is you can do everything if you're automated from your computer. We have apps for your phone. You can get on and make adjustments from your cell phone. So if you're at your kid's baseball game, football game, choir, whatever you're at, you can literally get on your phone and make adjustments to your plunger. You can make adjustments to your compressor. You can speed your compressor up, slow it down. You can add injection to wells. You can take injection away from wells. You can adjust chemical pumps. I mean, there's so much you can do if you're automated that you can't do if you've just got these standalone boxes. And the cost is more in the beginning for the automation, but what we found is you'll pay that cost off in 6 months or less. just with the uptick in production and what you're not spending on overtime and having to have your guys out there away from their families and working more because they're having to fix these little issues that come up. Batteries die in the plunger box. They don't know it for 24 hours because they can't see, their plunger runs.
Yeah.
The latch valve inside those things, that they'll get a little bit of salt or something go through the gas that's supposed to be dry gas going through a drip pot. Well, they forgot to drain the drip pot. Now they've got salt or scale or something, some trash in that latch valve, and so the latch valve went out, so the well's not opening and closing. Whereas automation, you're going to get a text, email, you're going to get something that says, hey, you've got an issue, we need to get it looked at.
So some of these operators, companies out there, they're not, especially in this market, their CAPEX is cut. They're not going to spend a bunch of money on automation upgrades. They might. Mm-hmm. We have a few clients that are actually doing it, and it's really exciting for them because they see the benefit on it. But right now, cash is king, trying to keep everything. So the standalone boxes, if they have that, what would you recommend to your operators of how to adjust, pretty well, the run times? Like when they get out there, what are they looking for? Shut down at 15 minutes or needs to go every 30?
Well, honestly, so if they've got a standalone box and they've got a SCADA system on location that measures their gas, you can see the flow, and you can see when the plunger, is shut in because your flow stops and when it comes back on. So you can see all of that. So the biggest thing that I would suggest is look at that flow, and you can see when, the wells and afterflow, how it starts to tail off, and you can see it loading because your flow rate starts to drop. And so if you see that flow rate drop, like really dramatic drop, that right there is when you really want to shut in, because that's loading. So that's when you're pulling more fluid into your tubing column, and it's going to make it that much harder for that plunger to lift that load of fluid. So in timer boxes, you look at that, if they've got minute history, they can see, how far into afterflow that big drop in flow rate started. And so you can pinpoint, okay, so I was 6 minutes into a 15-minute afterflow when this happened. So let's take that back to give it 8 minutes of afterflow, so that you don't, lose a lot of production. But and by losing a lot of production, you're not going to really lose it, because you've lowered your afterflow, but your shutting times are the same. So you're still going to get the same amount of runs, probably a couple more runs throughout the day, which is going to average out on how much flow time you had. And then if you see that, giving it that 8 minutes of afterflow rather than 15 minutes, by cutting that afterflow back, well, maybe now you don't need as much shut-in time. So depending on what style plunger you're running, you might not need that shut-in time. And then a lot of these boxes also have more capability than what you're actually using. So I know some of the plunger boxes, because when I was a foreman, I worked with another plunger company that I knew quite well. I used a lot of their product, and with my automation guys and myself, we created a way to actually see the standalone box on my Signet. So my guys could see the plunger runs and everything. And eventually we got it to where they could make some of those adjustments. And it was a simple upgrade that it was like $750, I believe. And all they did was add a little cell modem to the box. They added a tab to my Signet. The guys clicked on that tab, and they could see their plunger runs, and they could make small adjustments to the time. Now, they couldn't run the plunger off of critical flow or load factor, which is really what you want to do if you have the capability. Or with our IDAC system, the computer will make all those adjustments without the operator having to do it. So, which is a phenomenal tool.
Well, that's what, so your plunger time, I guess, what would be the optimal plunger time, runtime that you would like to see from your operators?
So equipment and to not tear up your equipment and to have the best run time as far as plunger life goes, I like to see between 12 and 15-minute runs.
Okay.
That's optimal, in my opinion, just because number one, if you're coming 6,000, 10,000 feet from bottom and you're surfacing in less than 12 or 15 minutes, it's a rocket. 12 and 15 minutes at that depth is still pretty fast. But when you're carrying fluid, it kind of acts as a cushion and the plunger's not slamming.
Right.
But if you get less than 8 minutes, 8-minute runs, you're tearing up equipment. You're going to tear up springs in the lubricator. You're going to tear up your plunger. You're going to tear up bottom hole spring assembly. Bringing plungers on that quick. And I've had plungers that were making 8-minute runs and they ran great and had the best production at 8 minutes. But you have to look at everything. Well, how often are you checking that bottom hole spring assembly? How often are you having to fish out broken plungers, fish out different things that broke because it was running that hard and that hot? And all of that adds on to those LOEs. So if you're changing a plunger out every 10 days because it's making 8-minute runs or less, are you really getting your money's worth out of that $300, $400 plunger?
Yeah.
Or could you put a conventional plunger that's $100, $200 in that well and make a 15, 20-minute run and have a little more shut in and maintain your production and cut your costs? So the biggest thing is, how can you save money and keep production where it needs to be to keep the wells open and flowing?
That's right.
And the biggest key for me at that point, with having over 400 plungers, in the field, was taking wells that were using a bypass plunger and switching over to a conventional during, these downturns. And
that actually, you're getting really good at it. You just segued right into the next one, which is choosing the right plunger. So keep going with what you were saying. So how do you choose the right plunger?
So again, in like I said, in these downturns, when you're looking at your wells and how can you save and how can you cut costs, if you've got a plunger in the well that you're changing out, 10 days, 20 days, 30 days, every 60 days even, and you can go to a plunger that will last, 8, 9, 10 months, a year. I've had conventional plungers that were in the hole for 18 months and still probably could have ran longer, but we got our money's worth out of it. So you go through and you look at these wells and you make those decisions. Hey, we're changing this plunger out every 3 weeks, every month. We're having to get a new plunger in this well, and this plunger is $375, $425, whatever the cost is. Let's try conventional. What's it going to hurt to try conventional for a week, 2 weeks? If you don't lose a lot of production, 5 MCF, 10 MCF. And I know in some marginal wells, 5 MCF, 10 MCF, that's big. But you can also reduce that to where you maybe lose 1 MCF a day. But that loss, is it going to cover the cost of changing that plunger 10 times compared to that one plunger?
So that was another variable point that you would do is, I guess when you're a production foreman, you would kind of look at, we got high end plungers on this well. You would actually say, all right, the variable we can do is let's change it out, and you would see what the data was telling you afterwards, production data.
Yes.
Okay.
So you change that plunger out and you look at it and you make the decision. Well, hey, yeah, we lost a little bit in production, but does it justify us going back to the more expensive plunger that we're changing out 6 times compared to the one that we just spent? And 9 times out of 10, it didn't justify going back to that more expensive plunger. Now, when the market starts coming back and gas production or gas prices come up, oil prices come up, and everything's looking good market-wise, then you can go back and say, okay, let's go back to a fast fall, a bypass, ball and sleeve, whatever the case may be, and, see if we get a little bit more of a production uplift and can maintain it. But the good thing about like our IDAC system that Impact has is that system literally looks at your well, flow rate, production, pressures, and makes adjustments and takes all the guessing out of the lease operator's hands. So literally all that lease operator has to do is inspect his equipment, his plunger, pull it, inspect it, make sure it's still good. And anytime he gets an alarm on, it'll flag whether it's the separator or something at the wellhead that flagged and caused the plunger to start acting up. So it takes all the guessing away and will optimize that well 100% efficient. And I'm talking, we've had wells that were the plunger runs were within 4 seconds of each other, 24 hours straight.
Wow.
So, you would do good if you had a 15-minute run, a 12-minute run, a 10-minute run, a 15-minute run. I mean, those huge couple of minute variables. Whereas the system that we've created and that our engineers have created, what they did is they listened to myself, and so I have a lead that I brought with me from another company, and then we have another production foreman that was up in the Utah area. He is one of the operating partners, and so they took all the information that we talked about and we gave them, and they created this system. And so every day it gets smarter. And by getting smarter, I mean, they'll go in and make adjustments, and the data that this system collects is infinite. I mean, it'll collect as much as we want it to, and it's all cloud-based, so we can keep adding on to memory and memory and memory. And so every day it gets smarter, and they've literally used, so, hey, Chad, what was your biggest headache as running plungers? And I would tell them, and then they would go in and they'd make those adjustments, and you go out in the field, and it's really cool to see how smart it was, because things that we used to guess on, now I know for sure. This thing tells me when my plungers hit fluid. It tells me, when it's setting on bottom, how long it's set on bottom. Did I leave my well shut in for too long? And so this system will actually see that and correct it. So that,
and that's what you were saying earlier, kind of going into is the conventional versus fast fall plungers. So why did you want to focus on that?
So a lot of people will see a conventional plunger and they're like, oh man, well, my well has to be shut in, a minimum for some plungers of 15 minutes, but other plungers, 30, 45 minutes, depending on depth, because they fall so much slower. If I put a fast fall in, a bypass plunger, it can fall through flow, and so my wells open more. And in some cases, fast fall plungers are exactly where you want to be. But in most cases, especially when every penny counts on keeping, a well from being shut in, a conventional plunger, number one, it's cheaper. It's literally a quarter of the cost of a fast fall in most cases. And number two, it's going to last longer because it's not tripping 50, 60, 80 times in a day. So a conventional plunger, typically I would trip them 8, maybe 10 times in a day. So, and by tripping, that means shut in to surface, and then you afterflow the well, like, you maximize your afterflow. That's what you're focusing on at that point. And our IDAC system goes even further. It'll see when the plunger is sitting on bottom and has stopped moving, and we'll open that well back up and let the plunger come to surface, and then afterflow it out based off of that. So, and it'll calculate the load for you. It does everything. But
for you, I guess your opinion on the people that are going to watch this is, when would you recommend them to change? I mean, I guess especially in a down market. I mean, is it
in a down market?
Yeah,
what they need to really look at is these wells that are right on the cusp of being inefficient to keep open, by simply taking a more expensive plunger out of the well and dropping a conventional, or heck, there's some wells that you can even take the plunger completely out and intermit the well. You need to look at those things and take into consideration, well, hey, if I pull this fast fall plunger that costs me X amount and I put this cheaper one in, number one, it's going to last longer. Two, it's going to be less of a headache for my operator. And three, it's cheap. I mean, you can't put anything in your well that costs less other than intermitting the well or free flowing the well.
Yeah.
And,
so it's kind of, I guess you would kind of look at, I guess what would be the variable, like gas to liquid ratio when you're doing your like well reviews?
Go
ahead.
So we look at, gas to liquid ratio. We also look at all the costs that are going to that well. So when we're going through well reviews, we're looking at production, but we're looking at what our accounting department is seeing. Hey, this well is being charged for compression. Are we injecting on the well? This well is being charged for water hauling X amount of dollars. How much are we actually producing out of this well? Is that number correct? So you're looking at all these different numbers, different parts that have been changed on location. And so you're making sure that everything's being allocated to that well is correct. So that's one big thing. But then you've got to look at the expendables, your plungers, your seat and trims, different things that you're changing out that are affecting those LOE costs too. So, if you're charging 6 plungers to that well in a year, and you can charge 1 plunger to that well, and it keeps it from having to be shut in, it's a no-brainer.
Yeah.
To make that change. But again, that's something that as a foreman, superintendent, and even with your engineers, that you get in there and you look at together and you say, okay, so what can we do to this well to make it more efficient to where we can keep producing? Otherwise, this one right here, it may be shut in next week. And again, the more you end up having to shut in because of price and because of cost, at the end of the day, that's someone's job, because if you shut in half your field, you have to condense. And so the biggest goal is to not have to make those hard decisions. What can we do to keep producing and be most cost effective in the field? And so those are the questions you ask. So can we change something as simple as a plunger? Can we change something as simple as settings and keep these wells producing without shutting them in?
No, absolutely. And then that's what I liked your next topic you're going into is well knowledge and equipment. So when you were talking about this, I mean, this is I guess general well knowledge surface.
Yes. So the biggest thing as far as your well knowledge is, number one, talk to the guy that's out there every day. The person that is literally at the wellhead every day looking at it. And then two is, what equipment do you have on location? What's its capabilities? Do the research. So when I come in, I thought the Rock, which is an automation box that measures gas, it runs your plungers, it looks at your tanks, it does everything. And I thought that was the end all be all. I didn't like Total Flows because I didn't think ABB Total Flow, had the capability. Well, then when I get into a foreman's position and over 75% of my wells have Total Flows, and I start doing the research, Total Flow ABB has the exact same capability. There's a few more steps that you have to go through and different things you have to do to get it to that point, but it does have all those capabilities. So when I'm doing the research and I'm looking and I'm figuring out, hey, I can do more with this Total Flow than just measure my gas. I can actually run my plungers. I can see my plunger runs. I can do so much more with it. than what I thought. So knowing your equipment on location and what it's capable of, that honestly is equally as important as running a plunger or knowing how to start a compressor.
I like what you said with ConocoPhillips. What did they call it? Multi-skilled operator?
MSO, yes. Yeah.
No, that's a nice way of saying you got to know everything. So I mean, some of these guys, when they're first starting out, they're greenhorns or they're highly, very trained, specialized in one area. How did you, I guess, Conoco, Intervest, how did these guys start training into different areas? Because it is a domino effect.
Oh yeah. So the biggest thing that I did when I started training guys to operate that were really green is I would take them out to location and I would hand them a piece of paper and tell them to draw their equipment out and then label what each part was. Tell me which way this well is flowing. How does this piece of equipment work? And I would go through that and I would make them take notes all day throughout the process. And so then when something would break, I'd go out there and I'd say, okay, so where do we start here? And we would walk through every step on how to fix that part. So from shutting, this valve and that valve, releasing pressure here, double checking to make sure the pressure on the opposite side of that check is also gone. Every single step, teaching them from point A to point B. It's honestly like when you're teaching a kid how to ride a bike or how to walk. There's so many different things that you want them to know to get to the point that it's just second nature, jump on, go. And so there would be guys that would come out and, weeks later, they're not calling you anymore, asking you questions. And then there's guys that come out that, 6 to 8 months, they're still, calling and second guessing things. So each individual is always going to pick it up quicker and different. But every person that I've ever worked with and trained, they've always said, just one day, and it was like a light bulb just went off. And I instantly knew without picking up the phone to call you.
That's awesome.
So that's the biggest thing, is just making sure that they know what's on location, because simple things will get you hurt quick. And people don't realize, like on like a Bettis actuator, MVI with an MVI choke. So those things, when they're closed, there's still trapped pressure, and it may be, trapped 200 pounds in a 2-foot area. Well, that 200 pounds in a 2-foot area is more dangerous than 200 pounds in a 600-foot area.
Yeah.
And we had a guy end up with, I think 15 stitches in his hand because he didn't realize it, and he was pulling one of those top works apart, and that ceramic disc came out, and that pressure released, and it cut through, dang near severed his thumb. So, and out there on that day, there were several things, because at Intervest we did, it was like a incident review. Mm-hmm. So everybody that was involved had to come into a room with superintendents and safety, and we would go through exactly what happened throughout the day. Well, one of the things that was missed that day was the company man that was in charge that particular day wasn't standing over there with them and monitoring what they were doing and making sure that they had knowledge of what they were working on. So not only will knowledge help you figure out how to make that well perform better and produce better, but it will also keep your people from getting hurt. So absolutely, the more knowledge you have on your equipment and your locations, the better off you are.
Well, and that kind of leads into our next one, the more knowledge, because the more knowledge you have, a lot of people are joining us because they wanted to know your experience on cutting LOE, especially in a down market. So having that understanding, knowledge, you can really start figuring out where your variables are, and then you can start kind of focusing and optimizing. So I guess, what are your big takeaways during this down market?
So the biggest thing is, as a foreman, superintendent, the person that's in the office every day that deals with the vendors and the vendor relationship, the biggest thing is don't be afraid to ask for discounts.
Yeah.
I asked every time a vendor, someone walked through my door, hey, where are we cutting costs today? You know, and a lot of times it was, you know, they walk in, hey, what are you doing for lunch today? Well, I brought my lunch today, so let's cut the cost on this plunger that you're fixing to sell me, based off the fact that we're not going to lunch, you know.
Yeah.
Those things. So when a vendor takes foremen, superintendents, field hands to lunches, to all this, it comes back in one way or another. So if rather than taking me to lunch or buying, you know, me a golf game or doing this or doing that, how about you give me the best price you can and you save that money on your company credit card, and put it towards cutting my cost in my field.
Yeah.
And so I was never afraid to ask any vendors or negotiate my prices on my compression. You know, hey, I've got this compressor over here that is rated to move, you know, 10 million, but I've got my wells running and I'm only using 3 million. I don't need the extra horsepower. So do y'all want to pay to swap this unit out for me, a smaller unit, or do you want to cut the cost and we'll keep renting that one just at a lesser price a month? Right. Let me pay for the horsepower I'm using. And 9 times out of 10, they'd be, well, yeah, because we really don't want to have to pay to have a crane come out, pay to have my guys, you know, take this to the shop and completely rebuild it, rework it to send it to a new customer. Let's keep it out there because eventually you may need it. And we ended up 9 times out of 10, we would eventually need more horsepower, more compression. And we let them know, hey, yeah, y'all cut us a break. Now we're using more horsepower. You know, we had your guy come out and put valves back in, or whatever he did, adjust the pockets in the unit. And so now we're using it more. So let's go back up on the price, you know, and that's, you have to show them that you're going to be fair. You know, I negotiated.
So compression was one of the big LOE for you.
It was the largest. That was the highest cost that I had in my field was compression. My second highest was water hauling. So Intervest as a company, when I was with them, they negotiated and went into an alliance with a compression company. And so that helped us negotiate, you know, our prices quite a bit. By using that one compression company, we were able to negotiate prices. But then it got to the point that we figured out that we weren't really getting the best deal in that alliance, you know, as far as service and keeping our units running, the percentage of runtime. But then the second highest cost was water hauling for me. I didn't have the option of, you know, being able to poly our water to certain disposals and get the break of not having to haul it. So when it started out, we were thinking at like $1.50, $1.65 per barrel is what we were paying to have it hauled.
Wow.
And we negotiated that down to 90 cents per barrel. So, you know, those costs there, they help quite a bit. And then negotiating with your plunger companies, because what I found was, and that was one thing with Impact that they listen to with foremen is, you know, plunger companies, they'll come in, they'll say, okay, well, this company has 8,000 wells, this company has 20,000. So the guy with 8,000 wells, he's going to pay more because he's not buying as many than the guy with 20,000. And so, you know, I knew, because oil and gas companies talk, and, you know, I have friends that still worked at Conoco. I had friends that worked at EOG. I had friends that worked, you know, in all these different companies, and, you know, we talk. So we know that, you know, Joe down the street is paying less per plunger than what I'm paying. And that didn't always sit well with me. And so that's one reason that Impact, all of our prices are on the internet. We don't hide anything. This is what everybody pays. We're by hands down, probably the most cost effective as far as price goes.
Well, that's what, like what you said earlier, it's it's a small industry. I mean, if you give cuts deals over here, now if the vendor can come back and explain, like, look, they buy $20,000 a month worth of stuff, that they're getting economies of scale. I can understand that. That's where it comes from. But if you're just doing it just to do it and get in the door, and yeah, everyone talks, especially in the oil and gas industry. It's always, it's always someone's brother-in-law or cousin, or that cousin that no one talks to, but somehow he knows everything that's going on. So So your biggest LOE costs were compression, then went into water hauling, and I guess third-party maintenance. Third-party services.
The next was the third-party services, which the biggest cost in that was plunger lift, and then your roustabout, your brake fixes, and that type of thing. And a lot of those costs were cut by making it to where my guys had more time to go out and work together and fix things, rather than, hey, call the roustabout crew and let's get them in and pay that $130, $140 an hour for the 3-man crew, and then there's 4-hour minimum, and it took them 30 minutes.
Absolutely. Well, let's go on to the next one. All right, so these are the upcoming webinars, so everyone stay on, because we will have a Q&A section in the end. So if you want to start typing in your questions, it'll start showing up. But our next speaker is going to be Terry Nelson, glycol dehydration expert. He works for WPI, very knowledgeable, Hanover Exterran experience. And then we got Jesus Olivares. He comes with his own company, oil and gas equipment manufacturer. He does a bunch of equipment, pressure vessels, skids, and he's going to be talking from his perspective of what to look for, how to optimize repairing existing equipment. So they will be coming in the next few weeks. If you're interested in being a webinar speaker or know of anyone, please give us a call. Let us know what's going on. Reach out to tori.balagura@crosssystems.net. We'd really like to have you come on board. So being continuous improvement, Six Sigma, we always like feedback. We've had great feedback on the last couple of webinars. So if we'll get an email outside of this, or there will be a pop-up right after this is done. Please give us your feedback. Let us know what's going on, and then you'll get a free hat or a shirt. Now, back into the Q&A section, this is all of our information. I'm here for you. Chad is here for you. So if you have anything else specific for your clients or for your business, engineers that want to learn a little bit more, please do reach out to us, so that way we can set that up for you. So if there's any questions right now, please put them in, but there is a couple of questions that came preloaded before this came in. So they're wanting to explain GAPL a little bit more.
Okay.
So Chad, can you explain what that is?
So GAPL is done many different ways. So if you've got the automation capabilities, so you can literally add gas lift to help. Basically what it does is you add a little gas lift to help the plunger surface and bring the load unload the fluid that it's carrying. So if you've got automation, you can set it up to where, Cameron, can you go back to that first slide that we had that had the picture of the well? Okay, so in this picture here, so if you look down at the ground, there's a Kimray at the bottom there on the ground beside the check valve. So what that Kimray is that's on the injection line. So yes, so that Kimray there, that's on the injection line. And so we've got it hooked up with a solenoid, and it tells that valve when to open and when to close. So say your plunger opens and it should have surfaced at 15 minutes, 12 minutes, whatever the normal plunger cycle is, and that plunger hasn't surfaced at that point. So that valve would open, give it a little injection, help get that fluid slug off, and then as soon as the plunger surfaces, it shuts it back off. So if you don't have the optimal or the automation capabilities or the capabilities to run solenoids to open and close these valves, than you do what is continuous gas lift, which is, it'll help you unload the well and help you unload the plunger. But if you give it too much injection, then you're just pressuring up your formation, holding your well back. So you're not going to produce it as efficiently as you can by constant injection. Whereas here, you can set it up many different ways. If the plunger doesn't surface at a certain time, that'll open, help the plunger surface. Say you only want to use gas lift during the rise cycle. So as soon as the well opens to let the plunger come back to surface, that valve would also open. Give it injection, and you can preset the injection how much you want. Give it that little injection. As soon as it surfaces, that valve shuts. You go into afterflow. The well's afterflowing, and you're lowering your formation pressure. So there's many different ways to run Gapple, and the best way is through automated valves.
Awesome. So we're going to go back. Oh, lost it.
Uh-oh.
Nah, you're fine. Let's go up. So we're actually going to, well, Chad, I appreciate you coming on board, talking with us, going through this. This is your day off also, so I appreciate you, I guess, coming on board, sharing your information with us, and it was great. It was exciting to talk to you. We're going to get your information. Again, if anyone out there is wanting more information, plunger lift optimization, just webinars, something that goes on, please let us know, and then we can get this information to you and start setting up these meetings. But I appreciate everybody for joining us, and if you need anything, please let us know.
Yeah, thanks for having me.
All right, thank you, Chad.
Mm-hmm.